Okay, so you guys, for our trig unit so far, we have reviewed SOHCAHTOA, we've reviewed sine law, cosine law, we have learned something called ambiguous case, and this one. And I want to remind you that you're going to have a quiz on all of these topics on Monday. What we're learning today is not going to be on the quiz on Monday, but you're going to have another quiz next week, Thursday, with all of this stuff. Okay, so I'm kind of splitting up the quizzes and making them smaller and more manageable. So our lesson today is called reciprocal trig ratios. And I want to start off by reminding you what the primary trig ratios are. Yeah. So we have reviewed sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. Now, you probably don't know this, but these are not the only trigonometric ratios that exist. There's something called secondary trigonometric ratios or reciprocal. These are cosecant, which are given the symbol CSC, secant, which is given the symbol SEC, and cotangent, which is given the symbol COT. And they're very closely related to sine, cos, and tan because they're just the reciprocal. And what that means is, if you look at these formulas over here, cosecant is just 1 divided by sine theta, secant is 1 divided by cos theta, and tangent is 1 divided by tan theta. An easy way that I remember this is I think of opposites. So the C is always with the S and the S is always with the C. So cosecant with sine, and then secant is with cosine, and then cotangent and tangent both have tangent in the names. So how do we calculate these? Well, because it's the reciprocal, you're basically going to flip around, SOHCAHTOA, you're going to flip around all the letters. So cosecant is going to be equal to hypotenuse over opposite, secant is going to be hypotenuse over adjacent, and cotangent is going to be adjacent over opposite. Now you're probably asking yourself, what is the point of this? And to be honest, I've researched this a lot. I don't know what the point of this is, because really, if you know sine, cos, and tan, you can answer all the different questions. In fact, when you're given these ones, we're going to convert them to sine, cos, and tan and then solve them anyways. I'm sure there was a use for them maybe before calculators were invented, maybe back in the day. For now, in terms of calculations, I find them to be pretty useless. That being said, you will see these words often, and you just need to learn how to convert them to sine, cos, and tan, and then do your calculation that way. Yep. Just started. Okay, so how exactly are we going to do the calculations for these? Let's take a look at this triangle. And by the way, I'm just going to let you know that hypotenuse, if you were to calculate it using the Pythagorean theorem, it would just be 13.6 centimeters. So instead of taking the time to calculate that, I'll just let you know it's 13.6 centimeters. Sine theta, and we have theta over here, which means according to this is opposite, this is adjacent, and this is the hypotenuse. So sine theta is just going to be 8 over 13.6. Cos theta is going to be 11 over 13.6. And tan theta is going to be 8 over 11. So really, this is the stuff we have been doing for a long time. Let's just get through this question, then I'll answer your question. For the reciprocal trig ratios, cosecant, you can think of it as the opposite of sine. So if sine theta is opposite over hypotenuse, cosecant theta is going to be hypotenuse over opposite. So it's going to be 13.6 divided by 8. Secant theta is going to be the reciprocal or the flip of cosine. So if cosine is adjacent over hypotenuse, secant is going to be hypotenuse over adjacent. And then cotangent is going to be the flip or the reciprocal of cotangent. So it's going to be adjacent over opposite. Okay, now can you find buttons on your calculator that have cosecant, secant, and cotangent? You can look for them, and the answer is no. So if I gave you something like secant is equal to 13.6 over 11, how would you calculate that? Like I said, secant is useless. You would actually have to convert it to cos and then calculate it from there. So you cannot calculate cosecant, secant, and cotangent on a calculator. You got to change them to the primary trig ratios and then calculate from there. All right, question number 2, state the corresponding reciprocal ratios for each of the following. So when you've been given Oh, I kind of don't like that I use the exact same color. Can we change that? There we go. When you've been given ratios and the words sine, cosine, tan, here's how we would solve this question. Sine theta, what is the corresponding secondary trig ratio to sine? Look at the chart. What's besides the sine? I heard it. Yeah, so you're going to write cosecant theta. And then all you do is you take the reciprocal of the ratio. So instead of 1/2, it's going to be 2/1. And that's literally what this question is saying. State the corresponding reciprocal ratio. It just means the corresponding secondary ratio. What is the secondary ratio to tangent? Look at the chart and you could just say it out loud. Yep, it's going to be cotangent theta is equal to 8/3. And how about for cosecant? It's going to be secant theta is equal to 5/2. So really part of your homework today is just to memorize these words, make sure you know the symbols, make sure what they belong with. Okay, now we're gonna go the opposite way. For question number 3, I've given you 3 of the secondary ratios, and we're gonna try to figure out what the primary ratios are. So when you have something like 1.25, try to change it into a fraction if you can, and if not, you can just put it as 1.25/1. Luckily, 1.25 can be rewritten. It's 1 1/4. Actually, I'll write it here. 1 1/4, which is the same as 5/4. So really, this question is asking us if this is cotangent theta is equal to 5/4, what is the corresponding primary ratio to cotangent? Tan theta is going to be equal to 4/5. The primary ratio to cosecant is what? Good, so we're just going to write this as sine theta is equal to 9/15. And then for secant, it's cos theta is equal to √2/1 or just √2. Okay, let's get into some calculations. Let's try and evaluate these to 4 decimal places. So we're going to start off with something very basic. Make sure your calculator is in degree modes. When I give you something like sine 52, we all know we're just going to be plugging in that information. We're not using sine inverse because we're not trying to find an angle. We're just figuring out what sine 52 is. And it says 4 decimal places. So this is going to be 0.7880. Now, how do you calculate for something like secant 24? Well, first we're going to rewrite it in one of these forms. So see how we have these over here? We're just going to rewrite whatever the secondary trig ratio is in a primary trig ratio form. So secant theta is 1/cos theta. That means secant 24 is the same as 1/cos 24. And now to calculate that, you're going to go 1 divided by cos 24. Yep, 1.0946, perfect. And then the last one, cotangent 38. We're going to go back to your chart, just take a look at what you would do. You're going to notice it's 1/tan 38. 1 divided by tan 38. And I get 1.2799. Okay, so hopefully you guys can see why I said this was useless, because you're literally just converting it to the original form. Question number 5, determine the angle measured to the nearest degree. So again, we start off with something we're really familiar with. cos theta is equal to 0.7951. When you're trying to find the angle, remember, you're always going to be using the inverse button. So like sine, cos, or tan to the power of -1, right? So you always, whatever it is, sine, cos, or tan, -1. That's what you're looking for. So to solve for theta in this question, we are going to go second function cos, or whatever your calculator does, 0.7951. And we're just rounding. I'm getting 37 degrees. Anyone else? Yeah. Now remember, I said we're always going to round to 1 decimal place, but of course, if the question is asking you to round to a specific number, then that is what you're going to have to do. Okay, so that's good. That's easy. But what do we do when we have cosecant or something like this? So technically, this is like saying cosecant theta is equal to 1.9888 over 1. We can rewrite this and make it sine theta is equal to 1 over 1.9888. So remember the exercise we did for questions 2 and 3, where we were just flipping it around? We're doing the same thing, except in this case, if it's just a decimal number, always put it over 1. And then when you're rewriting it, it's 1 over that same number. So now in your calculator, you're going to go ahead and go sine inverse of that entire fraction. So sine inverse 1 divided by 1.9888, and closest whole number, what do you guys get? I got 30 degrees. So, okay. So do sine inverse 1 divided by 1.9888, and then I get 30. For the next one, this is going to be tan theta is equal to 1 over 5.7426. So we're going to go tan inverse, and it's going to be 1 divided by 5.7426. And if you round it to the closest whole number, I'm getting 10 degrees for that one. So here's another useless question, question number 6, because it says, find the missing angle using the reciprocal trigonometric ratios. Why is this silly? Well, look at this. If we say that this is our angle dot or theta, I know that this is, sorry, just going to use this. So if this is my angle, I know this is opposite, this is adjacent, and this is the hypotenuse. If I'm trying to find that angle just using SOHCAHTOA, what am I going to use? Sine, cosine, or tangent? Tan. So we can very easily solve this question just by going tan theta is equal to opposite over adjacent and solve it. The question is forcing us to use secant, cosecant, or cotangent for no reason at all. So we're going to have to use a reciprocal ratio. If we would have used tan in the original question, what's the reciprocal related to tan? Cotangent, yeah. So we're going to go cotangent theta is equal to not opposite over adjacent, but adjacent over opposite. So it's going to be 12 over 5. Now, can we solve anything using cotangent? Is it useful to us at all? No. So what do we have to do? We have to convert it to tan theta is equal to 5 over 12. Exactly. Jeff? Let's keep going. So now we're going to go tan inverse. I just make things super awkward. I have a habit of doing that. Theta is going to be equal to, remember, you're using a tan inverse. And when there's no instructions given, I just use 1 decimal place. So it's going to be 22.6 degrees. Go ahead and do the same thing for the second useless diagram. Maybe I should be more positive. Yeah, I honestly know. So this is opposite, and this is the hypotenuse, and this is adjacent. So I'm going to use sine. So cosecant theta is equal to hey, not right now. Let's wait till we're done this. And then to solve the rest of the question, we're going to go sine inverse 1.4 divided by 2.7, and I'm getting 31.2 degrees. Did you guys get that as well? Not using this. Okay, so the question says, from a distance of 50 meters away from the base of a pole, Sally measures the angle of elevation to the top of the flag at 16.8 degrees. If Sally is 1.6 meters tall, use a reciprocal trigonometric ratio to calculate how tall the flag is. Okay, so let's draw a little picture. We know that there is some sort of flagpole over here, and then we know this is the ground, and we know Sally's standing there and looking up at the flagpole. I'll explain what I'm doing with this, but this is just what I am a little bit envisioning. Okay, so in this diagram, this right here is the pole. And this right here is Sally. So Sally has a certain height, and the pole has a certain height, and she is looking up at the pole at an angle of elevation of 16.8. This is actually one of the questions that was on your sheet. Some of you were trying it, and I know you asked questions about it, but I remember we had skipped this question. So let's just do it now. From a distance of 15 meters away, so I know that this base right here is 50 meters. And Sally measures the angle of elevation to be 16.8 degrees. So this right here is 16.8. Sally is 1.6 meters tall. So this right here is 1.6 meters tall. And we're trying to figure out this entire length over here, which is X. Yeah. So I already know that this height right here, from here to here, it's 1.6. So really, we need to just figure out what that X is and then add it on to the 1.6. Now, we have to use a reciprocal trig ratio. So what we're going to do is we're going to, if this is our angle over here, this is going to be opposite and this is going to be adjacent. So if we have an opposite and adjacent side length, we should be using tan, and the opposite of that is, or the reciprocal of that is, good. So we're going to go cotangent theta is equal to, if tan is opposite over adjacent, cotangent is adjacent over opposite. So it's going to be 50 over X. Hey. Yep. Tangent to tan. So it's going to be tan theta is equal to X over 50. And then, oh, sorry, I know what tan is, right? Yeah, we know what the angle is. So I'm going to just go ahead and put that in. Tan of 16.8 is going to be 50, not 50, X over 50. And then to solve for X, it's going to be tan 16.8 times 50. Yeah. Yeah, like right here, I should have put cotangent 16.8. So we figured out what X is, and now to figure out how tall the actual flag is. We're just going to add 15.0958 meters plus 1.67 meters, because that's how tall, oh, why did I press clear? 958 16.8 times 50 plus 1.67. So I'm getting 16 point, and we'll round it. So 16.8 meters tall. That's the end of our first lesson. Your homework is actually just textbook questions. So it's on the bottom left-hand side. I'm going to stop this now.